Good morning. Today we're going to be talking about logarithmic functions and their relationship to exponentials as inverses. So remember to take your time as you go through the notes to make sure you get the learning objective. And also, when I say pause, make sure you do that as we go through so you can try out the problems. When you're done, you're going to have an Excel, and then tomorrow I'll be ready to do a Kahoot when you walk into class. The first thing I want you guys to do is to try out the warm-up and see what you remember from yesterday and how logarithms fit into the big picture. So go ahead and pause me, and when you're done, you can restart. Okay, so for the inverse, the first thing we want to do is we want to remember to switch the x and the y and then solve for y to get the inverse algebraically. So in the first one, we go through, we switch x and y, and then we want to add over our 3 and divide by 2. So we end up getting 1/2 x plus 3/2 equals the inverse of x, the inverse of f of x. And then for number 2, when you go through and you switch x and y, all of a sudden we get an exponential. And remember that we don't know how to solve those. The whole entire unit before, we were spending time putting one into the y1, one into the y2, and seeing where they intersect. And unfortunately, we can't do this in this one. So that's why we need logarithms to help us solve exponentials. So before we go on, I want you guys to take a look at these next 3 problems. And you're welcome to, it says give with your partner. I know I'm not here. So you can talk to someone sitting around you, or you can try them on your own. But figure out how you can make, if you get rid of the word log, how can you make true statements with these exponentials? So go ahead and give them a try. And when you're done, go ahead and unpause me. So pause me now. Okay, so for example, the first one, we're looking at the numbers 3, 9, and 2. So if I want to put these into an equation to have them make sense, I could say something like 3 squared equals 9. If you did 9 squared, that would not equal 3. If you did 2 to the 9th or 2 cubed, you wouldn't get a true statement. So the only way to organize those 3 numbers is to say 3 to the 2nd power equals 9. Now that that one maybe makes sense to you, what do you think you could do in the next one? If you are stuck, you can now pause and try again, or keep going. Okay, so the next one, we could say something like 6 to the 1st equals 6. And then the last one, we could say something like 2. Sorry about that. We could say something like 2 cubed equals 8. So 2, take that little itty bitty number to the 3rd power, and that equals 8. Now that we see how those numbers work together, this is our main rule on being able to rewrite them. If we have something that is log base A of B equals C, this number A becomes the base of your exponential. Whatever your logarithm equals becomes your exponent, and the answer to that exponential, the answer to your exponential becomes that big number in your logarithm. This is a main concept that you want to be able to go back and forth between the two. So now when we go back to the notes and we take a look at a couple examples, we can go through and we can rewrite the logarithms. So for example, this little guy is our base. Whatever your log equals is your exponent. 25 to the 1/2 power is 5. And of course, you can go through and check that in your calculator. For the next one, we would say something like 9, because our little numbers are base of our exponential. He's your exponent, and that equals 120. If there is no base written, our base is 10. So if we had, and I don't have an example here, if we had something like log 2 equals x, this base that we don't actually see here would be a base of 10. So 10 to the x equals 2. That's what we call our common logarithm. So that's just a little side note, something for you to keep in mind as we go on. And the next one is also unique because this one is an L and an N. The L and the N are talking about a natural log. So ln is our natural logarithm, and this is log, guess what, of base e. So this one would be log base e. That's what ln is. It's a very, very special one. It's the same thing as log base e. So if I rewrite it, it's log base e of x equals 3. So if we go through and rewrite this as an exponential, our base is e to the third power equals x. And then last but not least, we have b to the x equals a. Be able to go back and forth between them. So here we took an exponential and we wrote every single one as we started with logarithm and we wrote every single one as an exponential. So notice all of our answers here are all exponential equations when we started with a logarithm in all 4 of them. Now the next one, we're going to go ahead and do the same thing, but we're going to use mental math to solve. So for example, our base is x squared equals 100. So we want to think about what that number could be. So when you take the square root of both sides, we do get plus or minus 10, but in a logarithm, we can only have positive values for our base. So we just get one final answer of x equals 10. Try out number 6 and 7. You're going to take a break and then restart me after you try. So go ahead and pause. Okay, so we have 25 to the x equals 5, and we want to think about what do we do there. So 5 is the square root of 25, so x to the 1/2 power. 1/2 power is the same as square root, so that is the exponent. That makes it a true statement. And then the last one is 3 to the 5th equals x, which I believe is 243. I don't have a calculator on me, so you guys can go ahead and check that work. Okay, so now we're done with the first side. Let's go ahead and flip it over to the back. And now we're going to go ahead and we're going to rewrite each. We're going to go ahead and rewrite these as an exponential and use mental math to solve. Here we're evaluating logarithms, so I would go through and set all of them equal to x in order to help you solve them. So remember in number 8, we don't have a base. So if we don't see the base, we know that our base is 10. So 10 to the x power equals 1/10. So when you're solving or evaluating logarithm, you're always looking for the exponent. So in order to get that 10 to the bottom, we're going to need a negative exponent, and it is just 10, so x to the negative first. When you move on to the next one, we have e to the x equals 1. This was something that we talked about a lot in class. So anything to the 0 power equals 1. So in order to make that true, x has to be 0. And this is nice because you can actually plug it into your calculator. If you look on the left-hand side of your calculator, you will see that ln button, and you'll be able to type it in. All right, number 10, we would rewrite it as an exponential. 4 to the x equals 32, and we want to think about what that number is. Here we know x equals 2 is too big because we would get 16, and that's not big enough. X equals 3, we get 64, and that's too big. So one way to think about this is to change it to a different base. We could potentially rewrite 4 as 2 squared. So that equals 4, and then you have your x. 32 is 2 to the 5th. And if these two things are equal, then their exponents must be equal. So 2x equals 5. Divide both sides by 2, we get x equals 2.5, or 5/2, which makes sense because of what we had over here. X equals 2 was too small, x equals 3 was too big, so x equals 2.5. You can go ahead and try it. Now there's 3 for you guys to try out. You know the drill. I want you to try them all. Go ahead and write them as an exponential. Pause me, and when you're ready, go ahead and restart. Okay, so here we go. Remember to go ahead and set them all equal to x, and then rewrite them as an exponential. So we get 5 to the x equals 125. What makes that true? An x value of 3. The next one, 8 to the x equals 2. Well, the cubed root of 8 is 2. So the cubed root is the same as the 1/3 power. And yes, I'm asking you to think all the way back to December. And then last but not least, as an exponential, we have a base of e when we have the natural log. So we don't, it's kind of like that invisible value, or that invisible number. So remember that this is really log base e and then another e. That's what we're looking at here. So that's how we get e to the x equals e. Well, what makes that true? Only if it was the first power. So let's go ahead and continue and think a lot about going the other direction. So when we go in the other direction, we can think back to a problem that we just saw earlier this week. So if you buy a house for $250,000, we're just going to take this word problem that we did before and see how logarithms could be helpful. How long will it take your house to be worth $300,000? So how long? Well, how did we do this before? We had to use our calculator. So let's take a look and see what happens. So with the first one, we have our initial value is $250,000. We have it appreciating at 4%. So 1.04, the 4% on top of the value. We're going to see how many years we're going to raise it to the x power, and we want to set it to $300,000. Now we have that variable in the exponent, and that's where the logs come in handy. So if you divide both sides by 250,000, when we divide both sides, we end up getting 1.4x. 300,000 divided by 250,000 equals, I believe, 1.2. Same thing, I don't have a calculator, so we can double check the math. And now notice that we have that variable in the exponent, and we would have had to do y1, y2. But now if we rewrite this as a log, we get log 1.04 is your base. We have 1.2 as our final answer, and x is our exponent. Now this becomes something that we can do in our calculator. If you go to math in your calculator, and we're going to talk about this in coming days, and you scroll down, there is something called log base, and you can type this in directly to help you get that answer. Go ahead, try it out, and see if you find out it works, and if not, we'll go over it again on Thursday. Notice I just input the picture of what it would look like if you were indeed to use log base. So you can try that out. And like I said, again, we can go over it on Thursday as well. All right, the last two, we're going to go ahead and find some inverses and follow the rules that we did before. So the first thing that we're going to do is we're going to go ahead and switch x and y. So x equals log y minus 1, and then we want to solve for y. Well, right now the y is attached to this log. Log is never anything on its own. It always has to be attached and grouped with something. So I can't just get rid of this. It doesn't work that way. It always has to come with its other values. So now we're going to go ahead and in order to find the inverse, we're going to go ahead and write him as an exponential. Remember that right now there's no number here, and if there's no number with log, our base is 10. So our base is 10. Our log equals our exponent, so 10 to the x equals y minus 1. We're not done because we do want to find the inverse, so we're just going to go ahead and add 1 to both sides, and that is how we find our inverse. So notice that logs and exponentials are always inverses of each other. For the next one, that f of x, remember that that's the same thing as y, so y equals 2 to the x. Switch your x and your y, so x equals 2 to the y. And now, once again, we got to solve for that y. Well, we don't know how to do that because we can't get rid of that 2. So the opposite of that exponential is to go ahead and write them as a logarithm. So we're going to start by just writing the word log, and we haven't really done this yet. So I did do it above here, but our base is 2. Our answer to our logarithm is x, and our exponent is always the answer. So here is our inverse to 2 to the x. Logs and exponentials will always be inverses of each other. So the big thing that I hope you got from today was that logs and exponentials are inverses, that you can write logs as exponentials and vice versa, exponentials as logs, and get that down in your head so that it'll help you with your solving as the next few days come. And your homework is Math Excel. And once again, be ready to walk in and be ready for the food tomorrow. Have a great day, and hope you enjoyed this really exciting award-winning video.